This is Math 3 2.2 notes. That's Math 3 Unit 2 Lesson 2 notes. And when you're doing this, make sure you put your name and period on here. Some of you are not, so make sure you write right up here your name and your period. And yeah, taking pictures, PDF it, all that at the end. Okay, accurately graph f of x and g of x on the same set of axes. F of x equals absolute value of x plus 2 minus 1, and g of x equals 1. A, where does f of x equal g of x? At what x value or values? Okay, so we're going to graph. I'm going to graph this first one here. Left 2, down 1. We know that already. And the slope is 1. So that's left 2, down 1. And the slope is positive 1. Up 1, over 1. Now, when I'm graphing to see where two graphs intersect, where they cross, I like to do all the dots I possibly can because I want to make sure my graph is exact, even if I'm using a ruler, or especially if you're not using a ruler, so you know where the points are exactly and your ruler didn't slide over or your freehand didn't get sloppy and you're not sure where the actual point should have been. So you want to be as accurate as you can. All right, I'm going to go ahead and draw that one just a smidge bit longer. It's not necessary, but I'd like it to at least match the other one. Okay, so this is f of x, and I'm going to graph g of x, and g of x is x equals 1. That's a horizontal line at 1. You don't have to use different colors, g of x. Okay, and now they're asking, look at the graph, where do the two functions equal? That means where do they cross, where do they intersect each other? And it happens there and there. And it's asking not two ordered pairs, just what are the two x values. Let's see, the one on the far left is 1, 2, 3, x is negative 4. And then that dot right there is x is 0. This is not an ordered pair. Do not put parentheses. These are two separate x values. The two lines equal each other when x is 4 and x is 0. Meaning if you were to plug 4 in here, it would be equal to the g function. You can try it. I'm sorry, negative 4. Negative 4 plus 2 is negative 2. The absolute value of negative 2 is 2, and 2 minus 1 is 1. It does work. You can plug in 0. 0 plus 2 is 2. The absolute value of 2 is 2, and 2 minus 1 is 1. So these are the two x values where the blue line will equal the green line. The blue absolute value will equal the green line. All right, algebraically, you set them equal. The absolute value of x plus 2 minus 1 equals negative 1. All right, the first thing you're always going to want to do is isolate the radical. Isolate, and I said radical, but I meant absolute value. We're doing radicals in advanced math right now. Okay, first thing you're going to want to do is isolate the absolute value. That means isolate means to get it by itself, and we're going to do that by adding 1 to the other side. So you have the absolute value of x plus 2 equals 2. And here is how you solve it. Think about absolute values. I'm going to cover this really quick. If I had the absolute value of x equals 7, you would think, oh, it's 7. It's actually 7 or negative 7, and here's why. The absolute value of 7 equals 7, check, and the absolute value of negative 7 also equals 7. So when you're solving absolute values, there's a possibility of having two solutions, because the absolute value of 7 and the absolute value of negative 7 both come out to be positive 7. All right, so the inside, which is the x plus 2, can equal 2, and the inside, which is still x plus 2, could also equal negative 2. All right, why is that? Because the absolute value of this could be positive 2, or it could be negative 2, because the absolute value of both 2 and negative 2 is going to come out to be positive 2. Subtract your 2, x equals 0. Subtract your 2, x equals negative 4. My two solutions are 0 and negative 4, and indeed those are my two solutions here. These are not ordered pairs, so it doesn't matter the order in which you write them. And do not put parentheses. And I already showed you plugging it in that it did work. I'll show you one more time with the 0. 0 plus 2 is 2, absolute value of 2 is 2, and 2 minus 1 is 1. It works. All right, so we can see that it works actually plugging it in. Okay, next one. F of x equals the absolute value of x minus 3. So write 3, 1, 2, 3. Up 1 over 1 because that's the slope. And again, I just keep going and going because I want it to be exact. Okay. So, oh gosh darn it, I messed up here. So I'm going to fix that. All right. And I'm going to do this one in blue like I did earlier. All right, and then this is my f of x function, and my g of x is -2, and it's horizontal, a horizontal line. And this is my g of x function. I'm just labeling everything. And it's asking where the two functions equal to each other. Well, they're never going to equal each other. This is a linear line. It's never going to curve up and hit that line. This is linear absolute value. It's never going to wrap down and hit this line. So this would be never. It's never going to happen. How do we show that algebraically? The absolute value of x minus 3 equals -2. Now you would think, oh, I'm going to make it equal to -2 and +2. Just change it like I did up here on number 1. That's not correct. This is no solution. The reason is the absolute value of no number is ever going to equal a negative. Absolute value of any number is always positive, always. So there's never a time in the world where you're going to take the absolute value of anything and it's ever going to equal a -2. No solution, never going to happen, not possible. All right, moving on. This one, they're asking us to solve. That should be 3 through 6. I'll fix it before I give it to you guys. Solve the following absolute value equations for x and graph the solutions on a number line. If there is no solution, write none and explain why. Okay, I'm going to cross this part out and graph. And I left it in here because it's on your homework, and when you get to that part in your homework, I want you to scratch it off there as well. All right. Okay, solve. This is just basic solving like we did up here. 5x minus 2 equals 8, and 5x minus 2 equals -8, because it could equal +8. Absolute value of 8 is 8. Absolute value of -8 is still 8. All right, you're going to add 2 and get 10. 5x equals 10. Divide by 5 and get 2. You're going to add 2 and get -6. Divide by 5 and get -6/5. And those are your two solutions. I'm going to write them over here. X equals 2, comma, -6 over 5. That there is my solution set. There's two answers. All right, I'm going to skip to number 5 because it's a little bit easier than those two over there. 2x plus 7 equals 0. Now when I do it again, 2x plus 7 equals the opposite of 0. The opposite of 0 is 0. Like there is no such thing as the opposite of 0. It's still 0. So I don't have to solve that one because it's going to be exactly the same. So it's only going to have one solution. So that would be something like this, where the line just touches the vertex part of it. So it's only going to touch it right there at that one point. Not 2 points like it did here, not no solution like it did there. It's going to be only one solution. So subtract 7. 2x equals -7. Divide by 2. X equals -7/2. All right. 4 and 5, we're dealing with compositions and additions and funky stuff going on. Okay, f of x is 3x plus 5, g of x is the absolute value of x, and I want you to solve g of f of x. So remember, that's where you take whatever's on the inside and plug it into whatever's on the outside. The inside is f, so that's 3x plus 5. I'm going to plug it into the g function and set that equal to negative 11. Okay, my g function is the absolute value of x, and wherever x used to be, I'm going to plug in the 3x plus 5. Again, wherever the x used to be, I'm going to plug in the 3x plus 5. And I want that to equal negative 11. All right, so like we said earlier, no absolute value is ever going to equal any kind of negative number. It could equal 0 or positives, but it's never going to equal a negative, so that one again is no solution. So what are our possibilities? No solution, we've seen it algebraically, both of these are algebraically, and we've seen it graphically. The lines never intersect. It could have two solutions, like this one here, or it could have one solution like that one there. And I've already said it. It's like if you have an absolute value and the line barely intersects at just that one point. That would be a one solution. So two solutions, one solution, no solution. All right, last one. F of x equals absolute value of x, and g of x equals 2x minus 4. Solve 5 plus 3, what the heck does that mean, of x equals 20. Okay, this is new notation that you will need to know. I'm going to put it up here. Fog, when you see it like this is equivalent to f of g of x. And you'll see GOF as well, and that's equivalent to g of f of x. So when you see that little, it looks like a multiplication, but it's an open circle. It's really tiny. It's not f times g, it's f of g. So GOF and FOG, that little open, it's f of g of x or g of f of x, depending on what's on the outside. So I'm going to rewrite it. 5 plus 3 times f of g of x equals 20. I'm going to plug the g into the f function. I'm going to do that part. I'll put everything else around it. F is the absolute value of x, and in the x spot I'm going to put the g, which is 2x minus 4. All right, the 5 goes there, the 3 goes in front, and it equals 20. There's the 5, there's the 3. This right here is the f of g of x, the fog piece. F of g of x. I took 2x minus 4 and I plugged that whole thing into where x used to be. All right, I cannot add 5 plus 3 because 3 is attached to the absolute value. I cannot do 5 plus 3. It's like 5 plus 3x. They're not like terms. So I'm going to isolate. We talked about earlier isolating the absolute value. I'm going to do that by subtracting 5. 3 absolute value, 2x minus 4 equals 15. And it's still not isolated because I still have to divide the 3. I cannot distribute the 3. You cannot because it's absolute value. So we're going to divide by 3. Absolute value of 2x minus 4 equals 5. And now that we've isolated, there's no more plus or minus on the outside, there's no multiplication on the outside, we're going to solve. All right, so I do 2x minus 4 equals 5, and 2x minus 4 equals negative 5, and solve. All right, you would add the 4, get 2x equals 9, add the 4, 2x equals negative 1. And then you would divide both sides by 2. I'm running out of room. Divide both sides by 2 and you get 2 answers. X equals 9/2, comma, negative 1/2. So answers are not always going to come out to be nice whole numbers. Sometimes you get fractions, but fractions are our friends, so we don't freak out when we get them. And that is it for this lesson. Because we finished it, you don't have to wait until class time. You turn this in right now as soon as you're done, PDF it, and turn it into Google Classroom. That is it for this lesson.